Hi everyone. This is a short demonstration on the types of things that you'll be able to do when you complete the course. Today we'll be using data from the Gentry Transect Dataset. This is a dataset of woody plant vegetation transects collected by Alwyn Gentry over the course of 22 years. He was a globally renowned botanist and he collected or surveyed plant communities from over 200 sites from 6 different continents, and this dataset represents some of his work. We only have a few minutes, so I'll move quickly and I'll be using tools you won't have installed. Don't worry, this is the only day of the course where I won't encourage you to code along with me. So just follow along and I'll point out some nice features about R. The goal today isn't to understand everything, it's really to see where we're going. What we're looking at is actually a cloud instance of our studio. My laptop is on the fritz, perfect timing, and I'm working off of a borrowed Chrome laptop. You can't install applications like R Studio on Chrome, but for the demonstration, our Studio Cloud is good enough and it makes it easy to use RStudio through your browser. This is the typical setup. When you first open up RStudio, we'll be writing our code in this text editor, and it allows you to write notes to yourself or to your future self or to your collaborators to explain the code. One of the first things you typically do when you start a new session is to load the libraries that you'll be using. So today we'll be using a few libraries. BN is the Botanical Information and Ecology Network. They've been amassing botanical data, and this is one of their new R packages I'm really excited to start using. And raster allows us to work with spatial data so we can map out these plots, the sites. dplyr allows us to manipulate or transform data. And ggplot is the beloved graphical package. All right, so I've written out the code, but I actually haven't run anything yet. There's a few different ways to do that. Because I'm in the browser, I have to use this icon here. The next thing I want to do is download the Gentry Transect Dataset. To do that, I want to store it in this object called Gentry, and I'll use these functions from the BN package to download the Transect data set. And because the package is well documented, I know that there's this argument in here called political boundaries, and I want that set to be true. One of the advantages of R being open source is that people are able to develop different packages to solve particular problems. There are literally thousands of packages available. Not all of them are of high quality, but it's easy to tell the ones that are from the ones that aren't, usually because they have really good documentation and they're maintained over time. All right, again, I've written out the code, but I haven't run anything. And that might take a minute to download. It's a large data set, and now I see it in what's called our environment. The next thing I want to do is create another object called sites, and I want to create this object so that I can pull out the unique plots from this Gentry dataset. So I want to select these unique plot based on a few criteria, including plot name, latitude, and longitude. And I've got a bunch of open parentheses and brackets, so I'm doing some accounting. And this will allow me to identify those unique transect locations so we can extract environmental data later on. All right, now that I've got those unique site locations, the next thing I want to do is calculate species richness. Again, this is a common theme. I'll store this in an object called rich data. And I want to specify pretty specific criteria to select data from this Gentry dataset. The first criteria is I want to filter out all the plots that are in the New World because most of his plots are in the New World and I'm most familiar with that geographical region. And then in order to calculate richness, I first have to group by country and plot name. And then I can summarize and create a variable called richness, which is the count of plots, the count of species by plot by country. And I want to collect this data in a tabular form. All right, now we're ready to download the environmental data from WorldClim. WorldClim is a global interpolated database of climatic variables. It's quite useful. And I want to download those data into an object called BioClim using this get data function. And I can call it by name. I want to download these bioclimatic variables at a resolution of 10. And let me run these now. And you can see that it's downloading. So I've downloaded the data. I've calculated richness. I've selected unique sites. Now I need to combine the environmental data to the plots. In order to do that, I have to tell R that these sites, this sites object that I created contains spatial data. So I'll create another object and use this function called spatial points data frame. And I'll specify that the spatial coordinates are stored in longitude and latitude column headings. And again, I'm doing some accounting here. Open bracket, closed bracket, comma, sites. This is important. Telling R that these are spatial coordinates is important for working with spatial data because R needs to know that these are geographical coordinates for projecting data onto a three-dimensional globe. All right, now we have all the data we're interested in working with. We can do things like site spatial. Oh, we can plot bioclim data, bio12, which is precipitation. And you can see that this is a raster layer. It's stored in this raster stack with all the other variables that we downloaded from WorldClim. You can see there's higher precipitation in more equatorial zones. We can also plot all the Gentry plots, Gentry transects onto this map, we can visualize where they're located in space, and you can see that affinity for the New World. All right, now we're ready to extract environmental data for each transect. To do that, I'll create a new object, and I'll use this function called extract bioclimate variables for sites spatial, and I'll include the columns from our sites. And I'm ready to run. And now I want to combine the above with our species richness. So again, I'll create another object. This will be a recurring theme throughout your R journey. And I'll do an inner join to join together rich data with the bioclimate Gentry objects that I created. All right, now this object has all the data that I'm interested in. So it has all of the plot name, the country, the calculated species richness, and all those bioclimatic variables, as well as the latitude and longitude. Now we can see how richness relates to precipitation, which is stored as bio 12. To do that, we can call ggplot, and we're telling it that we're interested in plotting stuff from this particular object, and we want to define the aesthetics, including the x-axis as bio 12 or precipitation, the y-axis as richness, and we need to define a geometry. In this case, we're interested in a scatter plot, so we will define the geometry there. Let's go ahead and run this, and it's giving me a warning message, and there's one row containing missing values, so there was an NA in one of the rows, and that's fine. That's some warning messages are not uh, a cause of concern if you know what they mean. So in this plot, we can see, I don't know if there's much of a trend. These two outlier plots might be influencing an appearance of a trend. And we can see some of the default graphing parameters of ggplot, including this gray background and these white minor axis grid lines. So what's great about ggplot is that it allows you to build layers to produce the publication quality figures. So for example, let's say I don't like this gray background, so let's give me a classic theme, and you'll see the advantage of using R. I modify this small portion, rerun the code, and quickly produce a nicer plot. We can also clean up those axis labels. Let's capitalize richness and define precipitation. And that is in there. We can rerun that quickly. Oh, and I have it background. I have it wrong. I got the axes wrong. And we can quickly fix this. X equals precipitation. Yep. So you can see the benefit of being able to modify the code quickly and then rerunning to produce the results. All right, this was a quick overview of some of the types of things that you'll be able to do by the end of the course. You'll be able to download data and work with pretty large data sets. You'll be able to transform it and select data based on very specific criteria. And you'll be able to produce much more stunning visualizations than what we did here. But this was a small sample of what you'll be able to do. If you have any comments, feel free to add them in the discussion board for this week. And I'll see you in a little bit.